What is the factored form of x to the third minus 2x squared minus 15x? Always look for a common factor that you can factor out. X would be a common factor to those three terms. So if you factor an x out, divide each term by x, and that's what will go in parentheses. If you divide x to the third by x, that is x squared. If you divide negative 2x squared by x, that is negative 2x. And if you divide negative 15x by x, that would be negative 15. Then look inside the parentheses. Think, will that factor into two binomials? Well, the first terms of the two binomials make x squared, so they'd be x and x. The second terms of the two binomials multiply to make negative 15 and add to make that middle coefficient of negative 2. So think of two numbers that multiply to make negative 15 and add to make negative 2. It'd be negative 5 and 3. So completely factored, that is x times x minus 5 times x plus 3. Next, what is the factored form of x to the third minus x squared minus 12x? Once again, always look for a common factor that you can factor out. X is a common factor to those three terms. So if you factor an x out, divide each term by x, and that's what will go in parentheses. So if you divide x to the third by x, that is x squared. If you divide negative x squared by x, that is negative x. And if you divide negative 12x by x, that is negative 12. Then look inside the parentheses and think, will that factor into two binomials? Well, the first terms of the two binomials make x squared, that'd be x and x. And the second terms of the two binomials would multiply to make negative 12 and add to make that middle coefficient of negative 1. So think of two numbers that multiply to make negative 12 and add to make negative 1. It'd be negative 4 and 3. So completely factored, that is x times x minus 4 times x plus 3. What is the factored form of 9x to the third plus 6x squared minus 3x? Always look for a common factor that you can factor out. So look at the 9, the 6, and the negative 3. 3 would be a common factor to those three. And the x to the third, the x squared, and the x is a common factor there. So the common factor of those three terms is 3x. I'm going to factor 3x out, divide each term by 3x, and that's what goes inside the parentheses. So if you divide 9x to the third by 3x, it'd be 3x squared. Divide 6x squared by 3x, it'd be 2x. And if you divide negative 3x by 3x, that is negative 1. Now take a second look at those set of parentheses. Will it factor into two binomials? Well, you have a 3 in front of the x squared, so if it will factor, you'll have to do factoring by grouping. That's where you split that 2x into two terms. Their coefficients multiply to get what 3 times negative 1 is. So they multiply to get negative 3, and they add to get that middle coefficient of 2. So two numbers that multiply to get negative 3 and add to get 2 would be 3 and negative 1. So we're going to split that 2x into 3x and negative 1x. We still have that 3x squared out front, and we still have the minus 1 on the end, and you still have a 3x out in front of the parentheses. Now this is why it's called factoring by grouping. We're going to group those first two terms together, the 3x squared and the 3x, and factor out a common factor. 3x is a common factor to those two terms, so if you factor 3x out, you end up with x plus 1 in parentheses. And then the last two terms, we're going to factor out a common factor, but you have to get the same thing in the parentheses in order for this to work. So those last two terms, you might think to factor 1 out, but that won't do it. You have to factor a negative 1 out so that you get the same thing in the parentheses. So if you factor a negative 1 out of those last two terms, you end up with x plus 1 in parentheses. Now if you look at these two terms, 3x times x plus 1 and negative 1 times x plus 1 is a common factor to those two terms. So we're going to take an x plus 1 out of those two terms. When you take that out, it's just like erasing it with your eraser, you would be left with the 3x and the negative 1. So when you factor an x plus 1 out of that, you have 3x minus 1. Don't forget, you have the 3x out in front of both sets of parentheses. So 3x times 3x minus 1 times x plus 1, that is now completely factored. What is the factored form of 2x to the third plus 5x squared minus 12x? Once again, always look for a common factor that you can factor out. X would be a common factor to those three terms. So if you factor an x out, divide each term by x. Divide 2x to the third by x, that is 2x squared. If you divide 5x squared by x, that is 5x. And if you divide negative 12x by x, that is negative 12. Check that set of parentheses, see if that'll factor into two binomials. We have a 2 out in front of the x squared, so you have to do factoring by grouping if this is going to factor. Factoring by grouping, we're going to split this 5x into two terms. Their coefficients will multiply to get what 2 times negative 12 is, so they multiply to get negative 24, and they add to get that middle coefficient of 5. So two numbers that multiply to get negative 24 and add to get 5 would be 8 and negative 3. So you're going to split that 5x into 8x and negative 3x. We still have a 2x squared out in front of that and a minus 12 on the end. And we still have x out in front of the parentheses. And this is why it's called factoring by grouping. Group those first two terms together, the 2x squared and 8x, and factor out a common factor. 2x would be a common factor of those two terms. So if you take a 2x out of those two terms, you have x plus 4 in parentheses. And then the last two terms, we're going to factor out a common factor, but we have to get the same thing in the parentheses for this to work. So we're going to factor a negative 3 out. Instead of factoring a 3 out, you're going to factor a negative 3 out so that, again, you get x plus 4 in parentheses. So now we have 2x times x plus 4 minus 3 times x plus 4. X plus 4 is a common factor to those two terms. So take that x plus 4 out. It's just like erasing it. You're going to be left with that 2x and minus 3. So completely factored. This is x times 2x minus 3 times x plus 4. And that is letter H. When you are working with graphs, keep in mind, where a graph crosses the x-axis, that could be called any of four things. It could be called a zero, a root, a solution, or an x-intercept. So where the graph hits the x-axis could be called zero, root, solution, or x-intercept. When the graph crosses the x-axis, the value of y is 0. That's why it's called a zero. To find where the graph crosses the x-axis, you would substitute 0 in for y into the equation. So where it hits the x-axis, in this case it's hitting the x-axis at negative 1, at 1, and at 2. Those could be called zeros, roots, solutions, or x-intercepts. What are the zeros of y equals x plus 2 times x minus 1 times x minus 3, and then graph the function? Well, to find the zeros, you're going to replace the y with 0, and then solve for x. So replace the y with 0. You have 0 equals x plus 2 times x minus 1 times x minus 3. Now to solve that for x, all three of those multiply together to equal 0. So set each one equal to 0, because if you have two or more things multiplied together equaling 0, any of those could be 0. So x plus 2 could be 0, x minus 1 could be 0, or x minus 3 could be 0. Then solve each one of those for x. You get x equals negative 2, x equals 1, or x equals 3. So those are the zeros, the roots, the solutions, the x-intercepts to that equation. To graph this, now keep in mind you're much more accurate graphing something like this on a graphing calculator than you are on paper, but we'll do our best. To graph this, we're going to plot the x-intercepts. So put those zeros on the graph. So that's where it hits the x-axis at negative 2, at 1, and also at 3. Those are the x-intercepts. Next step would be to find points for x values between the zeros. So determine x values between the zeros. For example, you might go with x being negative 1, with x being 0, or with x being 2. And then substitute those in. We're going to start with negative 1. If you substitute negative 1 in for x into that equation, you'd have negative 1 plus 2 times negative 1 minus 1 times negative 1 minus 3. Then work through that. It's going to be 1 times negative 2 times negative 4. And that is going to be positive 8. So when x is negative 1, y is 8. So go to the left 1 and up 8. Put a point there. There'll be another point on the graph. Then substitute 0 in for x. So when you substitute 0 in for x, it's going to be 0 plus 2 times 0 minus 1 times 0 minus 3. Well, that would just be 2 times negative 1 times negative 3. And that turns out to be positive 6. So when x is 0, y is 6. So just go up 6 on the y-axis and put a point. Finally, substitute 2 in for x. So if you substitute 2 in for x, replace the x's with 2's. It's going to be 2 plus 2 times 2 minus 1 times 2 minus 3. Work through that. That would be 4 times 1 times negative 1. And that turns out to be negative 4. So when x is 2, y is negative 4. Go to the right 2 and down 4. Now you have a lot of points on the graph. You're not sure how to connect those points. Think about the end behavior of the graph. What is it doing on the left side? What is it doing on the right side? So to determine the end behavior, if you multiply x plus 2 times x minus 1 times x minus 3 with the FOIL method and distributive property, you would end up with that leading term being x to the third. Because if you look at these, the x, and the x, those are all going to be multiplied together to make that leading term. So the leading term is going to be x to the third. And think about that leading term. the leading coefficient is positive and the degree is odd. If the leading coefficient is positive and the degree is odd, the end behavior will be down on the left side and up on the right side. So what's going to happen here is you can start your graph down on the left side and go up through that set of points, come back down and finish off going up. So the end behavior is down on the left, but then it finishes off up on the right. Once again, you're more accurate graphing this with the graphing calculator, and it would look nice and neat just like that. So that is the graph of that equation. The x-intercepts are -2, 1, and also 3. What are the zeros of the polynomial function y equals x minus 3 times 2x plus 1 times x minus 1? Well, to find the zeros, just replace the y with 0. If you replace the y with 0, you'd have 0 equals x minus 3 times 2x plus 1 times x minus 1. There, the y gets replaced with 0 finally. These three multiply together to equal 0, so set each one equal to 0. Set x minus 3 equal to 0, 2x plus 1 equal to 0, and x minus 1 equal to 0. If you have two or more things multiplied together equaling 0, any of those could be equal to 0. Then solve each one of those simple equations for x. In that first one, add 3 to both sides, you get x equals 3. In the second one, subtract 1 from each side, you have 2x equals -1. In that third one, add 1 to both sides, you get x equals 1. So two of these are already done, x equals 3 and x equals 1. In the middle, still have one more step to do, and that is to divide each side by 2. If you divide each side by 2, you end up with x equals -1/2 there. So x equals 3, x equals -1/2, x equals 1. Those are the zeros, the x-intercepts, the roots, the solutions to that equation. More importantly, it's answer C. What is a cubic polynomial function in standard form with zeros of -2, 2, and 3? So the -2, 2, and 3, those are the zeros, the roots, the solutions, the x-intercepts to that polynomial function. So we're going to work backwards from the solutions back up to the equation or the function itself. So right now we know that x equals -2, x equals 2, and x equals 3. Think of solving an equation for x, and then think of going backwards through that process. Those are your solutions for x. We're going to get each one of those equal to 0. So we're going to add 2 to both sides of that first equation, get x plus 2 equals 0. Subtract 2 from each side of that second equation, get x minus 2 equals 0. In that third equation, subtract 3 from each side to have x minus 3 equals 0. Now those three, x plus 2, the x minus 2 and the x minus 3, they're all equal to 0. So if all three of those are equal to 0, that means you could multiply all three of those together and set that equal to 0. Now we need to multiply through that to get rid of the parentheses. With the x plus 2 times x minus 2, you could use the FOIL method or distributive property, but you could also realize that's going to produce a difference of two squares. That's going to be x squared minus 4. So we have x squared minus 4 times x minus 3. Now you need to use the FOIL method or distributive property to multiply those. So take x squared times x, it's going to be x to the third. X squared times -3, it's -3x squared. Then -4 times x is -4x. And finally, -4 times -3 is plus 12. Take a quick look at that, make sure there are no like terms to combine, which there are not. So that is it. Just replace the 0 with f of x, and you'd have f of x equals x to the third minus 3x squared minus 4x plus 12. That is the polynomial function in standard form, decreasing order of the exponents, that has these zeros, -2, 2, and 3. If you graph that, it would hit the x-axis at -2, 2, and 3. Also the end behavior. Since you have x to the third out front, since that leading term is x to the third, the leading coefficient is positive, the degree is odd. Think about your linear functions. When you have y equals x, what's the end behavior on that? It's down on the left and up on the right. So the end behavior on that graph would be down on the left, up on the right, and it would hit the x-axis at -2, 2, and 3. What is a quartic function? That means the degree of that would be 4. What is a quartic function in standard form with zeros of -2, -2, 2, and 3? So those are the zeros. That is what x is equal to. X is equal to -2, -2 again, and 2 and 3. So to get the quartic function in standard form, get each of these equal to 0, as we did up there. So in that first equation, add 2 to both sides, you have x plus 2 equals 0. Use that -2 again, you have x plus 2 equals 0 again. Then x equals 2, change that to be x minus 2 equals 0, and that x equals 3, subtract 3 from each side, you have x minus 3 equals 0. So we got each of those equal to 0. That means if each of those is equal to 0, if you multiply all of those together, that will be equal to 0. So x plus 2 times x plus 2 times x minus 2 times x minus 3, that is equal to 0. Yes, you need both x plus 2's. Because of that fourth power, that quartic function, you need all 4 zeros, even if they do repeat. So now to multiply those, you have to go use the FOIL method or distributive property with the x plus 2 times x plus 2 out front. FOIL method or distributive property there, that's going to be x squared plus 4x plus 4. Also, with the x minus 2 times x minus 3, FOIL method or distributive property, that would be x squared minus 5x plus 6. Now, you can throw the FOIL method out the door because that only applies to multiplying two binomials. That's why I really don't like the FOIL method. Distributive property is always the way to go because that's what you have to use here. You have to distribute the x squared through that second set of parentheses, then distribute the 4x through that second set of parentheses, and finally distribute the 4 through that second set of parentheses. So we're going to distribute each one of these terms through that second set of parentheses. When you do that, the final product, when you combine the like terms, so when you use the distributive property and combine the like terms, this is what you get. X to the fourth minus x to the third minus 10x squared plus 4x and plus 24. That's still equal to 0. To write this in standard form, in professional form, it'd be f of x, or in this case g of x, equals x to the fourth minus x to the third minus 10x squared plus 4x plus 24, and you are now a professional. Which is the cubic polynomial in standard form with roots of 3, -6, and 0. So the 3, -6, and 0 would be the roots, the solutions, the zeros, the x-intercepts, whatever you want to call it. Well, we're looking for a cubic polynomial, so the first thing that catches my eye is the x squared in A and the x squared in B. Those are quadratic polynomials. We're going to throw those out immediately. They're out of the game. So we have x to the third minus 3x squared minus 18x, or x to the third plus 3x squared minus 18x. Close game between those two. The only difference is minus 3x squared or plus 3x squared. Well, we know the solutions. We know x equals 3, x equals -6, and also x equals 0. So if we get each one of those equal to 0, then we can multiply those together. So in that first equation, subtract 3 from each side, you have x minus 3 equals 0. In that second equation, add 6 to both sides, you have x plus 6 equals 0. In that third one, it's already done, x equals 0. So now, x minus 3, x plus 6, and x, they all equal 0. So if they all equal 0, that means you can multiply those three together. Doesn't matter what order you multiply those in. We'll take x times x minus 3 times x plus 6. That is equal to 0. So to multiply those, you could either distribute the x first, or you could use the FOIL method distributive property with the x minus 3 times x plus 6. Your choice. I'm going to multiply x minus 3 times x plus 6. If you do that with the FOIL method distributive property, it'd be x squared plus 3x minus 18. We still have that x out front, so distribute that through the set of parentheses. Take x times x squared, that'd be x to the third. X times 3x is 3x squared. And finally, x times -18, that is -18x. So you have x to the third plus 3x squared minus 18x equals 0. That is the cubic polynomial in standard form with roots of 3, -6, and 0. Letter D is the correct answer.